Hi, my name is Savannah Keene and my partner is Jacob Fullerton. We did a project called Give Me One Reason to Stay for our advanced ArcGIS programming class with Dr. Ames. I'm going to begin by stepping through some of the pre-processing for the data that we used. We began by getting the top 10 cities to live in the US from an online website by livability.com, but they can be obtained from any different source online and used in this script. The purpose of the project was to, out of these 10 cities, find the areas in the cities that were the best areas to live in and the most preferred based on um, closeness to highways, Walmarts, airports, and we chose to also do how close they were to universities. In the project, you didn't want to live too close to these, but you didn't want to live too far away either. So if you start by downloading your highway datasets for your cities and your municipality boundaries, and then we can start cleaning up from there. So in here you can see that we had raw data that we downloaded from the internet. This muni shapefile is the municipality boundary, and the Olmsted roads are the roads in this city as well. In ArcMap, if you drag those shapefiles in, you will be able to see that there are a lot of roads. In some of the shapefiles, it simply gave us freeway and highway roads, but others it gave us all the general roads in the city. So in this, we went in to the attributes table and we used the editor tool to select all of the main freeways and highways going in and out of the city, and then we exported those to a new shapefile. In this folder, you can see that when we cleaned up the data, we went through and created a folder for each city that we were analyzing. The city had two names like Palo Alto, an underscore was put in for this in between the names. In here you can see that for the municipality boundaries, the shapefiles were cleaned up and then renamed all to say city. And then the highways were cleaned up and then renamed to all say roads. This gave us a general base to go off of in our script. So the script will read through each municipality boundary as this city name, and each highway shapefile is this road's name. Once all of those were done and cleaned up and placed it in their respective folders, then shapefiles were created for Walmarts, airports, and universities. These could be obtained online, but are also easily drawn freehand if you would prefer that. As you can see, when I drop in the airports and I zoom into one of the cities that was worked on, here in Rochester, when the roads are turned off, you should be able to see the airports in the area. Here it was in a separate data frame, so it'll have to be re-put in into the right extent. We created by hand an airport shapefile. So when you drag and drop this in, you can see that a point was placed where an airport was. The same was done for universities and for Walmarts as well. Again, these can also be obtained online, but would take more cleaning up to be done to get them in the right format. So you can see where each of these point files were. Also, an extent shapefile was also created. This allows in the script for the extent of this boundary to be grabbed and be analyzed. That way, when you loop through each time, it's not analyzing the whole United States in just a specific city that you want it to. In each of these shapefiles, if you go into the attributes table, an add field was created and was named city. In each of these, it has this field with city with a capital C. That way, when the script runs through, it grabs the correct city that you're trying to analyze. In this instance, it would be Rochester. So it would grab just this data point for the airport. And in universities, it would just grab this data point and analyze that. And same with the Walmarts. Once that is created, you just have to go into your editor tool and add each of these city names to have that prepared for the script. Each of these city names needs to be exactly the same as it appears in the folder. So here you can see Santa Barbara is spelled with capital S and capital B with an underscore in between. The folder name is spelled the exact same way. This is important because the script is grabbing that name for the correct folder and the correct city and road contained in it. And then it's also using that to grab the correct data points in each of these shapefiles. Once all of the pre-processing for the data is complete, now you can move on to going through the script that will be run in the ArcMap.
This is the source code we used for making our maps for the livability of each city. Basic import, all of the tools we'll need for spatial analyst, extensions, and also the operating system and arcpy, pretty standard stuff. We also here ask the user to give us all of the city names of the folders, specifically 10 can be analyzed, have to be 10. And then we also ask the user to give us the undesirable buffer distances for the Walmarts, airports, and roads. And then we also ask for what they do want for the universities and Walmarts. We also identify where they want to save their PDF and where they want their cities to be found. These are contained, the cities are contained in that folder. Also get our geodatabase, set up our map document, and check to make sure that there isn't an atlas already there. If there is, we remove it, and then create a PDF doc in that location. Get the output coordinate system to standardize our projection for all of our data sets, and also get the extent shapefile drawn by the user, like we discussed a minute ago. Okay, here we take all of those cities and we make a list object. That way we can make it loop by city through each of the cities defined by the user. So going back to our function, our custom function here, it'll add a field called desire to each of our buffered regions, calculate it to be equal to 1 arbitrarily, and then convert that polygon into a raster. And take that raster and reclassify it to get rid of, or to reclassify any null or no data cells to be 0, as opposed to no data, allowing us to add it later. to other rasters. Then we save it. Okay, then we come in here, we set up our spatial extents. Our processing extents here are determined by the user again, like we mentioned, based on where they want the city to be analyzed. Collect all of our variables from the cities, and then we buffer them after we've projected them. I mentioned before, standardize where they're projected, and then select them and buffer them. Not too much special about that. And then here we've got our city municipal boundaries. We subtract what we don't want out of that to obtain the raster of the city. Raster of the Walmart, we want to be close enough but not too close. So that's here. That's our feature there. We're just subtracting out what we don't want. This is the input, this is what we don't want, and that's what we get out. And that's how close we do want to be to our universities. We call that custom function to produce those rasters, which we add up to get our acceptable raster. After we get that, we make a layer out of it and add it to our map with some transparency. Create our path for each city map that will be generated. Give it some time to catch up, make sure that we're not skipping past ArcMap. And then we have it update the title, and then we have it export after we set the zoom extents of that data frame. And then this loops back, and when it finishes all of the cities, it's done. So I'll go into ArcMap now and show you how to make the user interface. Alright, our code just barely finished. So I'm showing you some of the finished products here. But just to show briefly what this did, so I went through that code. So here we have all the different cities like we talked about, and now we've got our master atlas here. It's got several pages of the rasters showing where the better places to live are. Where the most intersects happen, where it's darkest, that's where it's the best place to live. So here you've only got 2 places that are really good. Anyway, as you can see, you go through each city, and that's that. So I'm going to show a little bit about the GUI. The way we made it work is these are all the default values currently. So these are the get parameters that we were talking about before to initialize everything. Nothing too spectacular about it. I'll show you what we did to make it so it would come up the way it did. We came in here, so when you click on properties of that script, come in here to parameters. So now most of these we want strings as far as the data type, so it comes in as a string. But then these folders, if you select the folder item, it lets you have that pick folder we were showing before, and then also the geos database is actually called workspace in this system, coordinate system, etc., and then shapefile. And the way you have to do it, you have to download your data like was explained, sort it into these folders, and that's how it works. Thank you very much for watching.